Introduction to Advanced Data Visualization. So, advanced data visualization refers to the techniques and practices that go beyond basic charts and graphs to represent complex data sets in a way that is both insightful and accessible. So, you want to leverage sophisticated visualization tools and methodologies to uncover and communicate deeper patterns, trends, and relationships within the data that might not be apparent from traditional visualization methods. So some of the key aspects of advanced data visualizations are complexity handling, interactivity, multi-dimensional representation, real-time visualization, customization and tailoring, narrative and storytelling, technical sophistication, and ethical considerations and accessibility. So if I were to delve into one aspect by aspect, so complexity handling, so we deal with high dimensional, large scale, and complex data sets that require more than just simple plots to understand. So advanced visualizations can encapsulate numerous variables and vast amounts of data in a single coherent visual format. What we mean by interactivity or advanced data visualization is the use of interactive elements that allow users to explore data in a hands-on manner. This can include capabilities like zooming, filtering, and dynamic coring, which enable users to drill down into specifics and view data from different perspectives. Multi-dimensional representation, when we mean by that, when we use advanced techniques, they are often employed to represent multiple dimensions of data simultaneously. So this will involve innovative use of axes, dimensions, and encodings. What we mean by encoding is like color, size, shape to convey additional layers of information. And real-time visualization is one of the ability to visualize data in real time. This is crucial for many fields where monitoring and decision-making processes happen frequently. So some of the advanced visualization tools can dynamically update to reflect live data feeds, providing up-to-the-minute insights, customization and tailoring. So advanced visualizations often require customization to effectively convey the unique insights of a data set. This can involve developing visual designs that is bespoke or combining different types of visualizations into a composite view. Narrative and storytelling. So when you use advanced data visualization, not only they are just about displaying data, it's also about telling a story with that data. And this involves structuring visualizations in a way that guides the viewer through a narrative, highlighting key insights and drawing conclusions. Technical sophistication. When you want to create an advanced visualization, it will often require a blend of skills. So not only just a deep understanding of data, but you need to have expertise in visualization tools and programming languages such as Python, R, or JavaScript, and a keen eye for design. Lastly, ethical considerations and accessibility, ensuring that visualizations are ethically sound, not misleading, and accessible to a broad audience, including those with disabilities, is really important part of advanced data visualizations. And you will see advanced data visualization in a wide range of domains. For example, business intelligence, scientific research, health informatics, financial analysis, social network analysis, among others. Principles of advanced data visualization. So advanced data visualization involves the use of sophisticated techniques and tools to represent complex data in a way that is both accessible and insightful for the viewer. And these principles are designed to handle multidimensional, large-scale, and complex data sets. By having that, it enables viewers to discover patterns, trends, and insight that might not be apparent from simpler visualizations. And here are 10 principles: multivariate analysis, high-dimensional data representation, interactive visualization, real-time data visualization, custom and composite visualization, storytelling with data, data density and scalability, integration of spatial and temporal data, accessibility and inclusivity, advanced interactivity and exploration. So we're gonna go on example of one example of advanced visualization. It's a bubble chart. So bubble chart is a type of data visualization that displays 3 dimensions of data. And you can see from this example, each entity with its triplet of associated data will be plotted as a disk, express 2 of values, and through the disk XY location, and the third through its size. So bubble charts are similar to scatter plots, but with the added feature and the size of the bubble can represent an additional dimension of the data. So when we look at characteristics of bubble chart, we would have x-axis and y-axis like scatter plot. So each bubble's position on the chart corresponds to its entities values along the 2 axes, and bubble size. So you can see that the size of each bubble represent the 3rd dimension of data, often a quantitative value, which means the larger the bubble, the greater the value it represents. And something that's used optionally is color coding. Bubbles can often be color coded to represent different categories or to add another layer of information to the chart. Some advantages of bubble charts are visual appeal and multidimensional data representation. The bubble charts can be visually engaging and can help to highlight significant data points effectively. And they allow for the visualization of data in 3 dimensions, which makes them useful for displaying more complex information. I'll say the disadvantages of bubble chart are 2 things. First is overlapping. Bubbles can overlap, especially with large data sets or closely situated data points, thus making it hard to discern individual bubbles. And there is an issue with quantitative precision. What we mean by that is that estimating the exact value of a data point based on bubble size can be challenging, which means making precise comparisons difficult. Some examples of use cases for bubble chart can be market research, economic analysis, healthcare data, environmental studies, education. For market research, example could be like you might be interested in comparing products or brands based on market share, and market share could be the bubble size, and the x-axis can be customer satisfaction, and brand loyalty could be y-axis. Economic analysis, you can visualize countries or regions based on GDP growth rate, and GDP growth rate could be in the x-axis, and population size could be the bubble size, and we can have another economic indicator like unemployment rate and y-axis. And can have education, so we can compare schools or departments by graduation rate. Graduation rate can be in the x-axis, and students-teacher ratio could be in the y-axis, and enrollment numbers can be the bubble size. So bubble chart versus color-coded scatter plot. Both bubble charts and color-coded scatter plots are powerful tools in data visualization. They both are used to represent multi-dimensional data sets. Although they share some similarity, they have distinct features that makes them suitable for different types of data and insights. So to compare like dimensionality, I would say both visualizations effectively show multi-dimensional data, but they do it differently. Bubble charts use the size of bubbles to add a quantitative dimension, while color-coded scatter plots use color to add either a categorical or a quantitative dimension. And there is a clarity and overlap differences. So for bubble chart, large bubbles in a bubble chart can overlap. It can potentially obscure data points. Color-coded scatter plots may avoid this issue with overlapping points, since points are typically smaller and colors can help distinguish overlapping points. And there's a difference between the interpretation for a bubble chart. Estimating the exact value represented by a bubble size can be more challenging than interpreting color, especially if the bubble sizes vary widely. So what should you do to choose between the two? So the choice between using a bubble chart or a color-coded scatter plot depends on the nature of the data and the specific insights you wish to convey. So if the third dimension of your data is quantitative and especially important to your analysis, a bubble chart might be more suitable. If you're looking to highlight distinction between categories or groups within your data, a color-coded scatter plot could be more effective. In both cases, I'll say it's important to design your visualization with clarity and ease of interpretation in mind to ensure that your audience can quickly understand the insights you're presenting. Funnel chart. So a funnel chart is a type of chart often used in business and marketing context to represent stages in a process and show the progressive reduction of data as it passes through these stages. So the shape of the funnel visually represent the idea that each stage in the process is smaller or contains fewer participants than the previous one, uh, which resembles a filtering process. So you can see that the key characteristics of funnel chart have stages. You can funnel charts are divided into multiple layers of stages, and the top layer is the widest, representing the largest set of data, and each subsequent layer narrows down. So this example shows the first stage being website visit, and then after that, downloads, potential customers, requested price, invoice sent. And these funnel charts are useful for visualization conversion rate at each stage. It can highlight where potential losses occur and where the process might be optimized. So examples of funnel charts would be website conversions. As you can see from the example, you can track a website visitor's track path from landing page through various actions like downloads, potential customer request price, invoice sent. This can help identifying pages or steps where users drop off. We can do something similar for any types of sales process or recruitment process or customer service tickets. So the benefits of funnel chart would be would help users to identify stages with significant drop-offs, or by showing that organizations can investigate and address issues. Candlestick charts. So you probably have seen this when you're looking at financial data. So it's because candlestick charts are a type of financial chart used to describe price movements of securities or currencies over time. They initially originated from Japan about more than 100 years ago, or initially to analyze rice contracts, and they have become popular in recent decades among traders and analysts in financial markets. So for key features, you can see that we have each candlestick, and these candlestick typically represent one trading period. One trading period can differ based on which market you're looking at. It could be day or hour, minute, and it shows the opening price, closing price, high price, and low price during that period. And how can you interpret this? If a candlestick where the close is higher than the open is considered bullish, it suggests buyers dominated the trading period. Conversely, candlestick where the close is lower than the open is considered bearish, which means sellers dominated the trading period. So you will see this in stock trading, commodity markets, or cryptocurrency analysis. So I'll say the benefits of candlestick charts are that they provide more information than a simple line chart. It offers insight into market sentiment and potential reversals. And the visual format of candlesticks makes it easier to spot trends and patterns over time compared to more traditional bar chart. However, there are some limitations. I would say the limitation is that candlestick charts are context dependent. What we mean by that is the significance of candlestick patterns can depend heavily on the broader market context and other technical indicators. Now, moving on to Sankey diagram. Sankey diagram is a type of flow diagram in which the width of the arrows is proportional to the flow rate or quantity of the flow. They are useful for visualizing material, energy, or cost transfers between processes. They help in understanding where resources come from, how they are used, where they end up. So you will notice that Sankey diagrams have directional flow, which means the path show the direction from one process or stage to another. It indicates how resources or data flow through a system, and the width of each flow line is proportional to its flow quantity. Therefore, it makes it easy to compare the sizes of different flows at a glance. So the example use case would be when you want to look at energy flow, such as production or consumption of energy within a system, or you can use Sankey diagram to illustrate how funds are allocated and spent within an organization or project. This can also be used to analyze user flow through a website. So the benefits of Sankey diagrams are that they are really intuitive. They make it easy to understand complex systems and flows at a glance. And by making the relative sizes of flows and losses visible, Sankey diagrams can help identify areas of inefficiency or waste. Moving on to next. Network graphs. So is a method used to represent relationships between entities in a graphical format. So network graph consists of nodes that represent the entities and edges that represent the relationships or connections between these entities. These are useful for visualizing complex interconnections. So examples of network graph uses are if you want to analyze social network, especially if you are interested in visualizing connections within social networks where nodes represent individuals and edges represent relationships, such as friendships or communications, you can create network graph to identify influencers or communities and the flow of information. You could use this to create biological networks. So you could illustrate interactions in biological systems such as maybe protein interaction networks, where nodes represent proteins and edges represent physical or functional interactions. Some of the benefits could be these network graphs can reveal patterns, clusters, and key nodes that may not be immediately apparent. So it helps you with analysis and decision-making process. So data visualization tools and software. So there are many tools and software that you can use. Here are some examples: Tableau, Power BI, D3JS, R, Python. So each tool or platforms have its own strengths and weaknesses. If I were to briefly mention Tableau, say it's easy to use because it's user-friendly, drag and drop interface kind of helps users to use without a programming background, and it has good integration with data sources like SQL databases, spreadsheets, cloud services. So Tableau is used a lot for business users who wants to create quick and interactive dashboards and report. I'll say Power BI is very similar to Tableau in a way that it has a drag and drop interface, but it integrates a lot better with other Microsoft products since Microsoft is the one who created this. And it not only integrates well with data sources like SQL databases, but it has a better support in integrating with other Microsoft products such as Azure, SQL Server, Excel. So you might consider using this if your organization is already using Microsoft. D3.js. D3.js is a JavaScript library that helps you to produce dynamic interactive data visualizations in web browser. This one, if you have a good understanding of JavaScript, you can use this. So this is more suitable for developers rather than non-technical users. Since it's a JavaScript library, it integrates well with web technologies and can be embedded in web applications. And R is similar to Python. It's just a different language, and R provides environments and language for statistical computing and graphics. So this one also requires user to be familiar with programming. It can integrate with many data sources and other languages, but compared to Tableau and Power BI, it won't feel as seamless. So Python also requires knowledge in programming and has libraries for data analysis and visualization. So if user has knowledge in programming and if there are a lot of tasks such as data analysis, machine learning, web development that needs to be done in Python, this would be ideal. So some of the best practices in data visualization is you want to make sure to uh, adjust the complexity of your visualization to the expertise and expectations of your audience. And you want to select a visualization type that best represents the structure and relationship within your data. To give an example, if you're comparing, you may want to use bar charts. If you are interested in seeing trends over time, you want to use line charts. Um, and you want to look at parts of a whole, you want to then pie chart. You also want to minimize any non-data ink by removing any unnecessary elements such as excessive labels, colors, or decorative graphics that don't add value to the data interpretation. And you want to use color to highlight important data points or differentiate elements, but you want to avoid overusing it because this can often lead to confusion. And it is important to include relevant references, lines, or thresholds to provide context for the data. And you want to make sure your visualizations accurately represent the underlying data without distorting or misleading the viewer. If you can, you want to add interactivity such as drill downs or tooltips to allow users to explore the data in more detail. And often you need to iterate on your visualization. So what you want to do is you test your visualization with a sample of your intended audience so you can gather feedback on its effectiveness. And when you are creating visualization, you always want to be mindful of privacy concerns and ethical considerations, especially if you are visualizing personal data. And lastly, this data visualization field is a rapidly evolving field, so it's important to stay informed about new tools, techniques, and best practices by engaging with the data visualization community. Emerging trends in data visualization. So these they are driven by advances in technology, increased data availability, and the growing importance of data-driven decision-making across industries. So what happened is tools like Tableau and Power BI continue to enhance their capabilities, so allow users to explore data through interactive elements like sliders, filters, and clickable elements. And you will more and more see the use of augmented reality and virtual reality for creating immersive data visualization experiences. And another thing happening in Insight is AI and machine learning are increasingly being integrated into visualization tools, and they help by automatically highlighting trends, outliers, and patterns. And with advances in web-based libraries such as D3.js and other 3.js and other React-based libraries, developers can create highly customized and interactive web-based visualization that can be integrated into websites and applications. And nowadays, there's more and more emphasis on storytelling with data. And there is also a stronger focus on making visualization accessible to users with disabilities. So there is more consideration for color blindness and screen reader compatibility. And scalability is another big thing. Since datasets grew in size, visualization tools and techniques, they are also evolving to handle large scale data. It there's more movement in open source. There are a lot more open source visualization tools. They're driven by communities, open source communities that contribute their development and making advanced visualization capabilities more accessible to a broader audience. That's it for advanced visualization. Thank you, everyone.